Hello, today, that is on Wednesday, June 25 at 2:31 am Eastern Time, Falcon 9 launched Axiom, SpaceX Axiom Mission 4 to International Space Station from Launch Complex 39A at NASA's Kennedy Space Center in Florida. Following stage separation, Falcon 9's first stage landed on Landing Zone 1 at Cape Canaveral Space Force Station in Florida. Dragon will autonomously dock with the space station on Thursday, that is on June 26 at approximately 7 am ET, followed by it getting into the details of the crew mission. The Axiom 4 crew includes members from India, Poland, Hungary, making each nation's first mission to the space station in history and the second government-sponsored human spaceflight mission in over 40 years. Shubhanshu Shukla will be India's second national astronaut to go to space since 1984. Sławosz Uznański European Space Agency project astronaut will be the second Polish astronaut since 1978. Tibor Kapu will be the second national Hungarian astronaut since 1980. Peggy Whitson will command her second commercial human spaceflight mission, adding to her standing record for the longest cumulative time in space by an American astronaut. Axiom 4 will be the second commercial spaceflight mission made up of government and European Space Agency sponsored national astronauts. The Axiom 4 mission stands as a beacon of opportunity for India, Poland and Hungary, each poised to leverage this mission to advance their national space programs. Okay, coming into the Axiom 4 mission research details, the Axiom 4 research complement includes around 60 scientific studies and activities representing 31 countries, including the US, India, Poland, Hungary, Saudi Arabia, Brazil, Nigeria, UAE, and nations across Europe. This will be the most research and science-related activities conducted on an Axiom space mission aboard the International Space Station to date, underscoring the mission's global significance and collaborative nature to advance microgravity research in low Earth orbit, that is LEO. The mission emphasizes scientific proof portfolios led by the US, India, Poland in partnership with European Space Agency and Hungary. It aims to boost participation in these countries by involving diverse stakeholders, showcasing the value of microgravity research and forecasting international collaboration. The studies will enhance global knowledge in the human research, Earth observation and life, biological and material sciences, demonstrating the space research capabilities of the crew's home nation. Coming to the research done by ISRO, we'll go through one by one. The first comes crop seeds on IS, International Space Station. This ISRO experiment will investigate the impacts of spaceflight on 6 variants of crop seeds. After the mission, seeds will be grown for multiple generations and plants showing preferred traits selected for genetic analysis. This project aims to help understand how crops may be grown in space for future exploration missions. Then the second one goes with cyanobacteria on International Space Station. Cyanobacteria are aquatic bacteria that can photosynthesize and are of interest of integration into spacecraft environmental control systems. This ISRO experiment will compare 2 strains of cyanobacteria to investigate growth rates, cellular responses, and biochemical activity in microgravity. The results could help with the development of future spacecraft life support systems. Coming to the third one, myogenesis, third experiment. This project aims to identify the pathways responsible for skeletal muscle dysfunction in microgravity and explore the therapeutical targeting strategies by studying how muscle loss occurs in space. The project seeks to pinpoint specific molecular mechanisms and potential interventions. Understanding these pathways is crucial for developing treatments to prevent muscle atrophy in astronauts during long space missions. On Earth, the findings could also impact the understanding of and treatments for muscle-related diseases and conditions related to aging and prolonged immobility. The fourth one comes STEM demonstrations. This will consist of 4 different STEM outreach activities for Indian students. The fifth one is Sprouts. This is the ISRO experiment will investigate the impacts of spaceflight on germination and growth of crop seeds. After the mission, seeds will be grown for multiple generations and The effects of genetic microbial load and nutritional profile investigated. This project aims to help understand how crops may be grown in space for future exploration missions. The next one comes space microalgae. Microalgae are potentially useful organisms for future spaceflight that could be used as food, fuel, or even used in life support systems. In this experiment, 3 strains of microalgae will be grown, and the impact of microgravity on the growth, metabolism, and genetic activity will be investigated versus algae grown on the ground. The 7th one comes Voyager displays. This experiment will investigate how the physical and cognitive impact of utilizing computer screens in microgravity. The research will study how pointing tasks, gaze fixation, and rapid eye movements are affected by being performed in space, and how this may interact with subjective experiments of stress well-being. The results could inform future spacecraft's computer design and interaction. The last one is Voyager tardigrades. This ISRO project will investigate the revival, survival, and reproduction of tardigrades sent to International Space Station. The project will examine the revival of dormant tardigrades, count the number of eggs laid and hatched during a mission, and compare the gene expression patterns of space-flown versus ground-controlled populations. The research seeks to identify molecular mechanisms of resilience, which has implications for understanding the limitations of life in extreme environments. This knowledge could inform future space exploration and help develop biotechnology applications on Earth. Okay, these are the 8 kind of experiments which are related to ISRO from those 60 scientific studies representing 31 countries. Okay, have a nice day. You can have a look at the video now. Thank you.
हम वापस अंतरिक्ष में पहुंच गए हैं और कमाल की राइड थी। इस समय हम 7.5 किलोमीटर प्रति सेकंड की रफ्तार से पृथ्वी के चारों तरफ घूम रहे हैं और मेरे कंधे पे मेरे साथ मेरा तिरंगा है जो मुझे बता रहा है कि नहीं हूँ, मैं आप सबके साथ हूँ। ये मेरी इंटरनेशनल स्पेस स्टेशन तक की जर्नी की शुरुआत नहीं है, ये भारत के ह्यूमन स्पेस प्रोग्राम की शुरुआत है और मैं चाहता हूं कि आप सभी देशवासी इस यात्रा का हिस्सा बने। आपका भी सीना गर्व से चौड़ा होना चाहिए, आप भी उतना ही एक्साइटमेंट दिखाइए। आइए हम सब मिलकर भारत के इस ह्यूमन स्पेस प्रोग्राम की जर्नी की शुरुआत करें। धन्यवाद। जय हिंद, जय भारत। बाद हम वापस अंतरिक्ष में पहुंच गए हैं और कमाल की राइड थी। इस समय हम 7.5 किलोमीटर प्रति सेकंड की रफ्तार से पृथ्वी के चारों तरफ घूम रहे हैं और मेरे कंधे पे मेरे साथ मेरा तिरंगा है जो मुझे बता रहा है कि नहीं हूँ, मैं आप सबके साथ हूँ। ये मेरी इंटरनेशनल स्पेस स्टेशन तक की जर्नी की शुरुआत नहीं है, ये भारत के ह्यूमन स्पेस प्रोग्राम की शुरुआत है और मैं चाहता हूं कि आप सभी देशवासी इस यात्रा का हिस्सा बने। आपका भी सीना गर्व से चौड़ा होना चाहिए, आप भी उतना ही एक्साइटमेंट दिखाइए। आइए हम सब मिलकर भारत के इस ह्यूमन स्पेस प्रोग्राम की जर्नी की शुरुआत करें।
The second stage launch load is complete. That should be coming up momentarily.
Stage 2, launch load complete.
There's that confirmation from mission control right on schedule. So the next major visual milestone we're likely to have from the outside of the spacecraft is going to be venting.
Auto idle.
Confirmation there from mission control that we are in auto idle on board Dragon in that final minute and a half before launch. Now we are expecting gas closeouts to be followed by some loud venting, and we're likely to see a larger cloud of liquid
Gas
oxygen.
closeout has started. Expect loud venting.
There's instructions to the crew also right on schedule. And a great nighttime shot of Dragon sitting there at historic launch complex 39A with the Ax-4 crew safely tucked inside with just over a minute to go until liftoff.
See left to right inside Dragon from this camera's perspective. You have Tibor Kapu there on the left-hand side, and beside him is our pilot, Shubhanshu Shukla, and to the other side
Falcon 9 startup and is now patrolling.
is Commander Peggy Whitson, and then on the far side is Sławosz Uznański-Wiśniewski of ESA.
Dragon SpaceX, go for launch.
Ax-4 is go for launch.
That is great news from mission control and from our crew on board Dragon. With that, we are just at T-minus 30
30
seconds
seconds.
to lift off of Ax-4.
Let's go Ax-4.
15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mission and liftoff.
For 3 nations, a new chapter in space takes flight. Godspeed Ax-4.
T plus 30 seconds into flight with the Axiom 4 crew on board Dragon, headed to the International Space Station. Waiting to hear call-outs from the Falcon 9 engineering team.
Power to launcher novel. Stage 1 throttle.
We're throttling down the 9 Merlin engines. We're into the throttle bucket, preparing for max Q.
Max Q. Vehicle is supersonic.
We should begin throttling the Merlin engines back up now.
Stage 1 throttle up.
Mission control confirming
Stage 1 Bravo.
that throttle up, and we are
Stage 1 Bravo.
steering our commander Peggy Whitson call out the first abort mode. Each of these are a specific phase where if for any reason we had an in-flight
Back
abort,
underway.
Dragon would abort to a safe location. So we're going to call out each of those milestones as we pass through them. We also just heard the call out for MVAC chill. We're going to trickle just a little bit of liquid oxygen now into the turbo pumps onboard our Merlin vacuum engine on stage 2 in preparation for second engine start 1, which will of course be shortly after stage separation. Now, at this point, we are just about 30 seconds away from 4 events that are going to happen in rapid succession. The first one will be main engine cutoff, or MECO, then again followed by stage separation, ignition of that second stage engine, which we are already preparing for, as well as the first stage's boost back burn. With that confirmation from mission control that we are throttling the first stage engines down, we are expecting MECO T plus 2 minutes and 26 seconds.
MECO. Stage separation confirmed. Stage 1 boost back startup. Back ignition.
There we had confirmation of all 4 of those events. Incredible views on our screen here too, as that boost back, as that first stage boosts its way back to Earth,
Stage 2 Alpha.
and confirmation from
Copy, 2
our
Alpha.
commander that we have entered the 2 Alpha abort mode. Of course, we're getting lots of cheers from behind us here at Mission Control here in Hawthorne, California as well. And at this point, our Ax-4 crew is on their way to space. The view you have on your screen right now is our MVAC engine burning for that second engine first burn. We're expecting that SECO here, second engine cutoff, which will likely be called out over the nets as SECO in just a couple of minutes.
Stage 1 boost back shutdown.
Confirmation that the boost back burn on our first stage booster is now complete, and the booster is heading back toward the Florida coast to attempt a landing at LZ1. At this point, stage 1 is actually still coasting to apogee. We're about to deploy those grid fins so that we can steer the vehicle as it enters the Earth's
Dragon
atmosphere.
SpaceX. Nominal trajectory.
And that call out for mission control means
Ready
that
copy. Nominal trajectory.
everything is right on track.
T plus 4 minutes, everything continuing to go well, and we've got our first view of the crew. They're inside Dragon, second